All right, so in this video, we'll take a look at the answers to the examples that I asked you to try. So I'm going to pull up Desmos because we've been focused on solving systems by graphing in this lesson. And Desmos is certainly a very helpful tool when we are graphing. So I'm going to type in example 1 just like it looks. So y equals x plus 2 and x equals negative 3. I'm going to hit the home button to put my screen back to normal. And I can see that they touch in one spot, which is negative 3, negative 1. All right, so if I were to just be graphing this system, I can graph my slope is 1 and my y-intercept is at 2. So let's put a y-intercept at 2. Our slope is up 1, right 1. Never hurts to review how to graph an equation. So I can graph that one, and then the second equation is just x equals negative 3. So you can go to x equals negative 3 and just put a nice vertical line right there. And then our solution we found with Desmos was at negative 3, negative 1. And then we can also use what you saw in the example on the notes. We can plug in x equals negative 3 and y equals negative 1 into our equations and make sure that they make sense. So if I plug it into this first equation, I can say y equals negative 1 when x equals negative 3, and just check that that would be a true statement. So negative 1 is equal to negative 3 plus 2, because that's equal to negative 1 as well. In the second one, it's very simple because you can just say negative 3 is our x value, and that does equal negative 3. So they both work in both of our, the solution works in both of our equations of our system. So negative 3, negative 1 was our solution. Hopefully you found that okay on your own. Number 2, let's just type this one in and take a look in Desmos. So I'm going to type y equals negative x squared minus x plus 12, and y equals x squared plus 7x plus 12. Pretty cool looking graph. So we have two solutions. Just be careful which points you click on, because like I said before, Desmos tries to be really helpful and show you some points that it thinks you're going to find important, but they're not always the ones that you need. So just be careful and pick out where, like on my graph, it's the green intersects with the blue. So that would be at negative 4, 0 and at 0, 12. But if you notice, there's this other little point Desmos is trying to point out to you. So just be careful what you click on. All right, so that's it for number 2. Hopefully you did okay with that, or that makes sense now. Let's look at number 3. So I'm going to type it into Desmos as well. I get y equals x minus 2 squared minus 3, and x squared plus y squared equals 136. So this one, if you zoom out a little bit, you notice is actually a circle and a parabola. So the green and the purple touch in those two places, and I would just round off to some reasonable numbers. So let's say negative 1.8 and 11.5 is one solution, and then let's say 5.6 and 10.2 would be my other solution. And let's look at this last example, our one little word problem for you to try. Hopefully you did okay. Katie and Connor are selling fruit for a school fundraiser. Customers can buy small boxes of oranges and large boxes of oranges. Katie sold 3 small boxes of oranges and 14 large boxes of oranges for a total of $208. So let's write down Katie's equation. So Katie sold 3 boxes of small oranges. Let's just call small x and large is the y. So Katie sold 3 small. So 3x, 14 large boxes. So 14y equals a total of $208. Connor sold 11 small boxes of oranges and 11 large boxes of oranges for a total of $220. So Connor sold 11 small plus 11 large. So 11x plus 11y equals $220. So I'm just going to write that as Connor. And this is Katie's equation. And we can just type them into Desmos and figure out our solution. So 3x plus 14y equals 208. And 11x plus 11y equals 220. All right. So we find that they intersect at the point 6,5. I'm just going to round that off. Or let's round off to 2 places since we're talking about cost. So $6.55 and $13.46. So the cost of a small box of oranges we found is, and we can refer back to our X was our small boxes. We just picked that out. As long as you keep it consistent, you can pick whichever letter for whichever type of box you wanted. And then Y was our large box variable. So the cost of a small box of oranges is $6.55. And a large box costs $13.46. Okay, so hopefully the notes in these examples can get you started on your homework. And thank you for listening.